Good afternoon, everybody. Welcome to class today. Thank you for joining me. Whether you are joining me live or whether you are watching the recording, I appreciate you watching. And this week we're starting Module 2, and Module 2 has a little bit of time to it. Right? We got a few weeks to deal with Module 2, although we don't have a bunch of content in Module 2. And in just a moment we'll talk about why all of that is. Right? Not a ton of content in Module 2, but we do have some time to deal with it. Before we get into that, I'm looking forward to having a look over your Module 1 assignments. I should be getting those graded a little bit later in the week. Got a lot of stuff going on this early in the semester. Right? I have a 8-week seated class that takes up at least 2 hours of every day, sometimes 3, if they need some more help after class during office hours and things like that. So, running hot here to start the semester, but especially after October the 12th. After all that's done, things should start moving a little more easily, a little more fluidly. Also, just as a reminder, we do have the study hall that's on Thursdays. I've hung out the last couple of weeks with nobody coming in to see me. Thursday is from 10:30 a.m. to 3:30 p.m. if you are able. And you have questions or you need help or you just want to come in and work for a little while, don't forget that the study hall is going down. So with that being said, we are starting Module 2 this week, and Module 2 is a little bit longer, primarily because I want you all to have plenty of time to install the environment, work in the environment, work any bugs out of the environment that you might get. Right at the end of this, I believe it's 3 weeks that we have kind of set aside for this. I want you all to have plenty of time to be able to install everything, set up the environment, get the sample code that we'll be using throughout the semester put into your environment so you have an active SQL environment that we can use for our assignments. And from there we will continue to work and continue to move forward. So we will have probably 2 live classes for this module instead of 3, just because there's not as much to talk about for this particular module. So we'll have the one that we're going to do today, and then we'll have another one where I kind of go through a little bit more information and do a sample query and work everything out there. So that's kind of going to be our plan for Module 2 here. And then for Module 3 going forward, right, we'll have a lot of stuff to talk about in each of these modules. So we will have plenty of time and plenty of things to talk about in everything else, just because there is so much to kind of cover and get through here. So we're still kind of easing into it for right now, but going forward from here, it is going to get a little more intense as we kind of go through. So just be aware of that. And I'm going to try to make it, as simple as possible. Right? One of the challenging parts about, going through this whole thing, once we get in deeper with some of the things that were going on in Module 3 and 4, is primarily going to be, what's a good word for it? Just logic. Right, being able to put things in the right order to get the right outcome, or the outcome of the information that we need. And so last week I posted that pre-recorded video for everybody, where I just talked about the idea of data and information in general. And so this week we're going to get into a little bit more depth. We're especially going to get into some more depth when it comes to relational databases here. So we're going to be talking more about relational databases today, what they are, what they do, and we'll start off with a little bit of review, and then we'll move into some more specific information. But the very first thing is just sort of a reminder of what is a database. Right, a database is a structured set of data held in a computer. And when we talked about databases in our pre-recorded video last week, we talked about a lot of different stuff, right? We talked about the idea of flat files and what a flat file was. We said that many of you have used a flat file, right? Because when we used that CSV file in the Python class last spring, that's basically just using a flat file database to have persistent storage of data. It's some sort of structure that's holding data. But we also said there are relational databases, which is going to be the kind of crux of what we're going to be looking at this semester, are relational databases. Specifically SQL, and even more specific than that, MySQL, the MySQL variant of our SQL databases. And so this is a structured set of data held in a computer. And for our purposes, as we're looking at a SQL database, this structure is going to support the storage and manipulation of data. And when we get into talking about kind of what SQL is specifically in just a few minutes, we'll talk about the 3 different languages that are built inside of SQL, right? Which is kind of interesting to think like, well, we're doing this one language, right? But there are other sorts of languages that are kind of built in to MySQL that are parts of the language. And these different parts of the language are kind of building up these structures and building up this manipulation of data. And when we say manipulation of data, we're not necessarily using manipulation in terms of, ways that you might have heard manipulation used before, right? We're not trying to introduce false data. Here, when we say manipulate, we're not trying to change the values of data. Instead, when we're saying manipulate here, all we're really trying to do is work with data to turn it into information, right? So like one of the things that we talked about last week was this idea of the information process, right? We said that we have data. Data is raw. Data is just, basically ones and zeros stored in, binary stored in a database on a computer that our computer doesn't really know what any of it means. Right? If there's one thing that I want you all to get out of the entire programming and web development program, it's that we are smart and our computers are dumb. And so when we get any meaning from any information that a computer gives us, then we are deriving that information ourselves, right? Our computer is just giving us a sequence of characters that it has no idea what it means, right? It has no idea, in terms of what a number is. It has no idea in terms of what a letter is, right? It just reads things as sequences of electrical impulses. And that gives it a representation of something that it can process, that it can communicate to us. Right, so when we're talking about manipulation of data in this sort of way, we're talking about primarily querying data in such a way, sending a request in to our data to go through a specific process to give us meaningful, valuable information on the output end. Right? So when we're talking about manipulation of data, just kind of keep that in mind. We're not really meaning, manipulating in terms of the nefarious definition of manipulation. Right? We mean more manipulating in terms of taking something that is raw and unprocessed and making it into valuable information. And there are all sorts of different types of databases, right? We talked about a lot of them last week. A couple of the examples that I always like to give are the, your shopper club card that you have. Right, in our area here, we primarily, it's Food Lion and it's Ingles grocery stores. And so the Food Lion has the MVP card. The Ingles grocery stores have the Ingles Advantage card. Basically every grocery company in the world right now, right, pretty much has their own version of these club cards. But what these club cards are essentially just the ability to get data, right? They tie it to discounts in the store, right? But that's more so an incentive to get you to use it so it can record the data. So whenever you go shopping, right, you get your groceries, you go up to the cashier, you hand them your club card, they scan it. What's on the back of that club card? It's a barcode. That barcode's tied to a number. That number is essentially your primary key in the database. Right? The primary key that's related to you. So by scanning that number on the back of your card, they're able to retrieve information about you, right? Because it can query that primary key. But they're also able to store information about you. Right? They're able to take, for example, the items that you're purchasing and store them in a database. And this can be used for multiple purposes, right? For example, if I want to make sure that you buy a product that I know you like, that's going to be going on sale coming up, I might want to make sure to send you a little bit of extra advertisement. Like, oh, we got big sales coming up in this department and this department. Right? And we know you like to buy from that department because we have the data that reflects, this person likes to shop in these departments. Another thing would be in determining what type of products that I send to stores. Right? So, for example, if I get a bunch of test products in an area, and I put them on the shelves and I leave them there for a few weeks, maybe a month, maybe 2. I'm recording purchase data, so I know every time one of these trial products has been bought. And if enough of them get purchased, then I would know to restock. I would know which flavors of something to restock maybe more often because they're more popular. Various other, things when it comes to that, right? So I'd get an idea that would help inform my purchasing decisions. Right, so at the end of the day, really, with every bit of information that we're, kind of garnering from these systems, where we're starting out with data, it's helping us make decisions about something. Right, another example is your student data here at Cleveland Community College. Right, there's a database that has your information in it, and this database is structured in different ways. Right, it might have multiple tables with multiple types of data being stored in each that are all going to be tied to your primary key, which is your student ID number. Right, if you remember what we talked about last time, a primary key in a database is essentially just a unique identifier for a record, so that we know that any data that's in any sort of relational database table ties to another database, the records in another database table, based on the presence of that key as the unique identifier. Right, so especially when we get into, in Module 3, we'll start to query multiple tables at one time to get data and turn it into information. Right, because we'll say, well, we have this database over here that has this information about how many games this person has played. And we have this table over here that has information that's this person's personal information. So we might say, oh, I want to get the total number of games played by a person from this particular town. And so we can write a query that kind of takes those different things, puts them together, and gives us a total number of all games played by a person from a particular town. So what might be the value in something like that, right? Well, I might be, if I do have a store, for example, I might be looking for a new location for that store. Especially if I know that people from like miles around are coming to visit it. Right, so if I'm in Gastonia or if I'm in maybe Cherokee County there in South Carolina, and I have a store there, and I'm thinking about adding a new location, and I see, a lot of people from Shelby are driving 30 minutes to the other side of Gastonia to visit this store, and they're spending a lot of money here. They might spend even more money, more regularly, if I put a location in Shelby. Right? So so we can take the data from your shopper card or from whatever we've got there. We have one table of data that has your personal information in it, that has the record of, where you're from, what your phone number is, what your address is. And then you have another table of data that includes records of the stuff that you're buying, how much money you're spending, and all that sort of stuff. So if I can see, like, oh, hey, I got a whole bunch of people that's spending a whole bunch of money in this store from this area that's way far away, I should put a store in their area so then they could stop by more often and buy more stuff. Right? At the end of the day, that's what a lot of this, just comes down to, is this idea of decision making. How we're going to use data that we have, turn it into information, and make it valuable to us. And so the key that we have here, especially when it comes to the idea of a relational database, is the idea of structure. Right? Structure here is really our key word. And when we think about how our data is stored, if you've ever seen these kind of Pyrex dishes or anything like that, we can kind of look at this as a series of nested containers. Right? Or if you've seen those Mastroikas, the Russian nesting dolls, right? Where you have, a container within a container within a container. Right? Because when we are dealing with our database, that's essentially what we're dealing with. Is we're dealing with a container within a container within a container within a container. So a box within a box within a box within a box. Right, and that's the structure that's being built here in our database. And so the idea of these, kind of nested containers, container and a container and a container, is a nice thing to think about when you're thinking about the concept of what a database is abstractly. But when we are applying it to something, we can apply it more in this sort of way, right? We have this idea of the overall structure of our database. The database itself is the overarching structure, right? So if we look at our little drawing that we have here, this outside box that we have here kind of represents our database itself. So our database itself is a structure. Right? And a database can contain multiple tables. And so if we look here at our drawing, we have one table on the inside of here. We only have one for our purposes here. But for all intents and purposes, if our big box here is a singular table, we can put, or rather a singular database, we can put multiple different tables of information inside of that database. And my hand was definitely not steady there, but you kind of get the idea. Right? I could put multiple tables of records inside of a single database. And if we use a primary key and maybe some things like a foreign key, these are all concepts that we'll talk about later on in the semester, we can take and we can relate between these databases, right? So since we're using these keys to identify these unique values, things in database A, database B, database C, so on and so forth, right? We can, or table A, table B, table C, I should say to be more accurate, can relate to one another, and so we can use the information there. Right? So when we're looking at each of these tables, and we'll talk more about how we make the decision in terms of what we put where, what we put in which table toward the end of the semester when we talk about data normalization. Right? That's how we make the decision as to how we divide up what's related into these tables. But all of our tables have some sort of relationship. The data inside the tables have a particular relationship to itself, right, to the data that's in that table, but there's also a relationship between that table and the other tables. For example, the one that I've been giving so far, right, is the idea of your student information. Right, your personal information, where you live, your phone number, that sort of stuff, that doesn't really tie directly to any of the classes that you've taken. Right, so in one table in our database, we'd have a table that has records of student personal information. So it would be your student ID, your name, your address, your phone number. And then in a completely separate table, we'd have a table of records of your of the classes that you've taken and maybe the grade that you've made in each of these classes. Right? Because you see the thing about that is that your personal information versus the class that you've taken, there's no real direct correlation to those, right? Like your address and the fact that you've taken Web 115 don't interfere with one another, right? You can move and you will still have taken Web 115. The only thing that relates these two tables together, your personal information and the classes you've taken, is the fact that they belong to you, right? They're related to you. So we would use the primary key as a foreign key in our other table. We'll talk about the differences between those in a future week. And so that we know that you have taken those classes belong to you. Right, and so even if we don't have your name as a record in the other table, we do have your student ID as a record in your other table, because your student ID is a record that is a unique identifier of you. Right, there are several instances under which your name might change. Right, for example, if you're a lady that's taking the married name of your husband and you get married, right? your name will change. But we want to make sure that all of your records still stay tied to you. So if we are focused on that primary key off that unique student ID number, that's a unique identifier of you, that doesn't change at all. Right, so it's a big deal in terms of, making sure our record keeping is good, our data remains consistent, even if other things change. Right, so we can have multiple of these tables. Each of these tables have their own specific purpose in the type of data they're collecting. They have some sort of value that allows you to relate one table to another, typically what we call the primary key. And when we get into this table, we have rows and columns, just like we would in a singular spreadsheet. Right? A row in a table we call a record. Right? So our records are all the data for a particular key that's involved with that table. Right? So as we're going left to right, it's going to be involved with the key, whether it is a primary key or a foreign key. Typically, for our purposes, they're going to be primary keys. That's going to be all the way to the left of that table. Right? That record is going to be dependent on that primary key. So it's going to be all the information about one person. Whereas the columns consist of a single data attribute, which is identified by the column header. So the column header has a singular data attribute. For example, if it was your personal information, the row would be your personal information, your name, your address, your phone number. Whereas the column would be everybody's address, everybody's phone number, so on and so forth, right? If we took this and put it into a bit of a different example, something like this. Right, here we have this idea of a structured example of a database, and this is just some personal information for an employee table. So if I'm working at company, right, company might have a human resources database, and that's what this would be a part of. And then I have this employee information table that's a part of my larger HR database, whatever we want to call it, right? I might have other tables that have different bits of information in it. Maybe how much sick leave you have, or how many vacation days you've accrued, or maybe your maybe something to do with your personnel files, maybe how many commendations you've received, or how many write-ups you've received, or maybe just your annual performance reviews. Might be stored in another database. But to keep things simple, this one here is just a regular employee information database. And so we can see here we have a table that's called employee. Right, so that's the name of our table. And we have these columns of information here. Employee ID, first name, last name, phone, and mail. And in this case, mail is the email address. Right, so we can see here that each of these column headers relate to the column of information that it is on top of. Right? Mail, everything going down underneath mail are all email addresses. Phone, everything going down underneath phone are all phone numbers. Last name, everything going down is all last name. first name, everything going down is all first name. ID underscore employee, everything going down is the employee ID. And in this case, ID underscore employee is our PK. Or our primary key, right? Not penalty kick in this instance. It's our primary key. And so this number is going to be unique for every single person. 1, 2, 3, 4, 5. Hypothetically, we'd go on into infinity based on, however many employees our company will ever have, right? When we get rid of an employee, whether they retire or whether they're terminated or something else happens to them, what have you, we will never reuse a primary key. Right? Our primary keys need to be unique for every single person, regardless of how many people down the road we're dealing with, right? Like, that's why student IDs, your student ID number is so high, right? Your student ID number, and I don't think it's exactly like this, but you can kind of think of it this way. Your student ID number is reflective of every single student that's ever been to Cleveland Community College. Right, it's not quite that way because, you could start your numbering system at a different place than 1. You can also, there's also a high degree of likelihood that we haven't been keeping up with student records like that since the college has been opened back in the 60s. Right, but you can kind of think of your student ID as the result of every student that's ever been to Cleveland Community College ever, even if the last class they took was 10 years ago. Right, because we still need to keep that primary key as a unique identifier in our database, so as to avoid confusion. Now, sometimes when databases get too big, we might do a data purge and get rid of data that is older than however long back. But especially with how cheap storage is and how little space our database is really taking up with our records, that's going to be a rare occasion when that has to happen, right? But in that case, what we would do is we would just say, if you were a customer or an employee before X date, you would have to re-register them before they would be back in the system, right? And you'd still start with new numbers. Also, I think that's an important thing to kind of suss out. You wouldn't reuse any of the old numbers. You just purge that data from the system and keep going up with your numbering system. You just make your database smaller by purging old data. But also, as we can kind of see here, each one of these lines going across each row or each record, again, which is what we use as our terminology here, is related to one specific employee. Employee with ID 1 is Big Boss. Their phone number is 936-854. $270, and that's a fake number, so it's the wrong number of numbers. And then their email address is big.boss@company.com. Right, and that's all the information related to a singular individual. Now, I did say that we have 3 different languages in SQL. right? And this is our DML, our DDL, and our DCL. And some people will even throw in some other ones depending on what you're looking at, right? Because some other people will also talk about a DQL, or data query language. But when we're looking at our different types of languages that are within HTML, we have our DML, which is our data manipulation language, our DDL, which is our data definition language, and our DCL, which is our data control language. And when we think about our data manipulation language, this is the part of the language that works with the tables. Right? So this is the kind of stuff we'll be doing when we get to Module 4. Right? Our data manipulation language. Basically these are all the SQL commands that deal with kind of the manipulation of data that's already present in the database. And this includes most of our SQL statements that we'll be using, right? Some of the big ones that we use are insert, update, delete, that sort of thing. These would also include a lot of the Module 3 stuff, right? When we come to our data querying. Some people take the data manipulation language piece and manipulate it and split it up with the data query language being its own thing versus the inserting, the updating, the deleting, and all that kind of stuff. But when we think about it, we can kind of think about it as all one big thing, right? It's just kind of what works with the data in the tables, right? So as we are returning data or we are adding data, it'll be our data manipulation part of our SQL language that we're using for that. When we think about the DQL part of this, those are going to be all of our select statements, which we put, for our intents and purposes, as a part of the data manipulation language here. But again, some people will kind of split the data manipulation language out into its own data query language and a separate data manipulation language. So the selects are basically our return statements, right? They're statements that get information for us from the database based on how we define our query. And then our others would be inserts and updates and deletes, things that are actually, changing information when we need it to be changed. Because we could at times need it to be changed. The DDL, or the data definition language, is what we use with the data in the tables. So when we're creating new tables, and this gets into more Module 4 stuff, right? We can kind of say data manipulation language is Module 3 and 4. Data definition language is more Module 4. Right? These are the SQL commands that define our schema, right? So our table has a name, right? And inside of our table, we have these columns, and these columns have a heading. But one thing that we've not talked about in relation to columns yet is that columns also have a data type. Right? So when we are establishing a column, we're also making a promise to our database that we're going to give it a specific type of information. So with our data definition language, this is when we're creating new tables. This is when we are dropping tables, altering the structure of our database, or doing some other things in relation to that. Our DCL is our data control language. This is for the access control of the database, right? Who has access to which parts? One of the things I think you all read about last week with our Module 1 information is that a big part of making the relational database a thing was this idea that we have multiple people that can work on one database at one time. Right? And that's super significant. For our purposes, because, oftentimes multiple people are working on a singular database at a singular time, right? Whether they're getting callbacks from it in relation to like query responses, or they are actively writing to it. Right? So being able to do that all at different times is significant. And so what I'd like to do, I think I'd like to just get into our database a little bit here, just to show you some stuff. Right, so let me open up MySQL Workbench. And we'll start having a little look at that. There's a video in the module that walks you through the MySQL setup process. One of the benefits to getting a new machine is I get to, I can update my install videos. Because even if you kind of have to wipe your hard drive and things with this software, uninstall it and delete all the data that was related to it, or else when you reinstall it, it'll have all the data still present when you reinstall. So it's hard to kind of work with there. But we can look at some of the schemas, which a schema is just a fancy word for just the way a database is laid out. For some of our tables that we'll be working with throughout the semester as we go through. So let me just click in here. We will log into Ooh, do I remember what I made my password? That might be a bit of a thing. Uh-oh, I might have to go back and fix that. Because I seem to have... Now we can fix that really quickly here. But this does go to show you the importance of something that I talked about in that video. Which is remembering the password that you used here. Let's see here. Let's try... I think the problem might be the user I'm working with here. Because it's using my root user instead of the other user that I worked with. Okay, that's not right. Try one more thing here. All right. Well, it looks like I'll have to save this for next week, and we'll try to get that figured out. I seem to have forgotten what I set it up with. Hopefully I wrote it down somewhere. So we will just save that for next week then, because we do have more time to go over all this. So that's where we'll stop for today. I obviously wanted to go a little bit longer here, but circumstances. Thank you again for watching. We'll get this sorted out before next week. Got plenty of time to work on all this stuff, so we're in good shape. Remember that as you are doing this, one of the reasons why we have this first module being so long is because I want to make sure everybody has a chance to get their environment up and running. If they do something like this, I want to have the chance to be able to troubleshoot everything so we can all have a good working environment before we actually get into the nitty-gritty and we're doing all the hard stuff that we'll be doing in a few weeks. So that's all that I have for you for today. We'll hang out and chat with the music playing for just a few minutes, just in case anybody here with me live has any questions. If you're watching the recording and you have questions, send me an email, let me know. But that's all that I have for you for now. Thank you for watching, and we'll see you next time.